Well, hi. Some of you I know, and some of you I only am meeting now. Um, I'm Linda Ginsberg, and I mostly teach math and look at how people learn math, especially adults. So, oops, let's see. Why? Okay, let's try it this way. Okay,
Yep, there you go.
so this is about algebra. And so, why focus on algebra so much? For one, it is one of the emphases on the current GED, and for the future GED, it's even going to be more important. But, it may be that people aren't going to be taking the GED in New Jersey, or some. Um, but if people want to go into further education in community colleges, what will happen is they will have to take the placement test, and there's a lot of algebra on that, and many people end up having to take algebra in developmental math. Most places have 3 developmental math courses. The first is a basic arithmetic, the second is a early algebra, and then a like algebra 2 second algebra course. So people need it for those purposes, but of course that's just for testing and not necessarily the meaning part of algebra. But the important part of algebra is that it's really powerful. It allows you to observe and generalize and model situations. And we'll talk about this and look at some examples to make that a little clearer to you. And the other thing I really want to stress is that algebra can be taught to learners at all levels. People don't have to, spend a year trying to deal with fractions before they do algebra. They can be doing algebra at the same time. And in fact, um, it makes good sense, since we are dealing with adults, to do that, because algebra is perceived as an adult-ish kind of part of math. People know that it's at that it's generally at the high school level. People feel less uh, mortified that they're studying the same thing their kids in 5th grade are studying. So if you can call things algebra, and you could look at algebra um, from whatever position learners are at, that only is empowering. And then there's the other side of that if we start helping people think about the algebra early on, then it's not such a shock when suddenly we're talking about something that has nothing to do with the math that people have been working on before. So if you can integrate components of algebra all the way through, you're helping learners make that transition really seamlessly, and also they can feel better about what they do, and they'll get a more deep understanding of the algebra that they can use as a foundation for further algebra. And so from some interviews with adult learners, these are how they described learning algebra in high school when they encountered it in high school. So Betty says, I used to always wonder, well, how do you add letters? How do letters come in? But nobody really explained. Or Lucille, who said, and these are women in their 40s and 50s, I think what made it so complicated looking to me was that I had to understand the X and the Y. And I think that always seemed so confusing, and how to get that full understanding of the X and the Y. Other than that, it just seemed like, oh my God, what the heck is this? I mean, those are not really uncommon experiences when people talk about, oh, I had math in high school, or I started math in high school and then I quit. Um, or this is one of my favorites, Dion, who says, when I think of algebra, I think algebra is something hard, something only smart people can do. Somebody, got glasses on with a lot of books in their hands. I gets to college and register, so she went to community college in Philadelphia has a program that if you haven't finished high school, if you can take a certain number of college courses, you basically get a high school diploma. So she tried doing that. And I gets to college and register and sign up for algebra class. had to drop it because I came into class and the teacher had numbers as long as the board. I look at it and I didn't understand it, not one bit. 4x here and 7, and I was like, what is that? And so these are not uncommon experiences for adults who are coming back to school in adult basic education courses. And so recognizing that people come with some usually very unhappy experiences with algebra or a lot of confusion about algebra really helps if you can acknowledge that and give them an opportunity to try and determine what was it about algebra that was so mysterious. Because I have quotes that I won't give you from these same people who, after spending a semester working in an adult ed class on algebra in a very informal way, they felt so empowered, and that they were saying, is this all it is? Well, you know, these letters just represent numbers and represent groups of numbers or categories or something. I mean, they became so articulate about what they were doing and why. It was really lovely. So thinking about what is algebraic thinking, and not only algebra, but you know, the kind of thinking that goes with it that enables somebody to deal with the algebra and to take it to the next level. So algebraic thinking has to do with looking for structure to make sense of situations, and we'll look at examples of these. And generalizing. The power of algebra is that you can look at a situation and come up with how does this work beyond the specific numbers. Also representing relationships in multiple ways. When algebra, often it's with tables, graphs, equations, but other times it can be with diagrams, with concrete objects. And so, you know, making the connections between things and reasoning logically to solve new problems. So what do you do with all this? As a teacher, you can take simple problems and expand them by changing conditions. What that means is, so I went to the store and bought 4 cans of frozen orange juice and 2 bottles of soda. And so I said, well, you know, okay, well, how about if you bought 5 bottles of soda and 2 bottles or 2 cans of orange juice? How would that be different? You know, what would happen with the money? And just kind of complicate problems. And all the way through asking probing questions like, how did you do that? Why'd you do it that way? Could you do it another way? So that the process is actually highlighted rather than the answer. I used to tell students, I don't care what the answer is, I want to know how you did it. And that was so frustrating for them at the beginning because they were so used to, I'm doing this so I can get a right answer, and if I don't have the right answer, I have to do something else. And often you can get a right or a wrong answer for all kinds of right or wrong reasons. And so it's really way more important to say, how did you do that? How did you get there? Why'd you do it that way? Can anybody come up with another way to do it? So that you're focusing on the understanding the relationships between numbers and seeing patterns and using symbols for generalizing. I know this is kind of abstract, but, and I hate that nobody can interrupt me. I hope you're still there. But we'll do some problems and you'll see maybe what I'm talking about. And the other part of the strategy is way less emphasis on routine procedures. Because what happens with routine procedures in isolation is people make mistakes because they don't understand why they're doing what they're doing. And this is a real problem. Because there are some big important misconceptions, and one of them is how the equal sign works. We have students, many students, who think of the equal sign to mean like if I said 4 plus 3 equals, the meaning of the equal sign is kind of like, and the answer is, and then they're supposed to put a 7. So you need to help people see that the equal sign is really the fulcrum of the balance, and that both sides of the equal sign have to be equivalent. So that's why people get really hung up with having an X on the right side instead of on the left side, because it doesn't look right, because they're thinking about the answer is always to the right, because we read left to right.
Linda,
So
Linda, I wanted to echo something I think that you said that was really important, not only in the area of math, but not always knowing why our students got a right answer, that they could be doing it for right reasons or wrong reasons. I see sometimes in literacy or comprehension when I see things like, multiple choice tests or vocabulary things with word banks and things like that. And we have no idea why students actually get the answers they get, right? They could be randomly choosing things, they could be doing some guesswork, but it doesn't give us a sense of what their reasoning is. And I think it's a really important point.
yeah, to me, it's really about how to teach math, especially. But you're talking about it in the context of literacy as well. That if you don't kind of probe and try and understand where the answer is coming from, or where the thinking is coming from, or the reasoning is coming from, there isn't a whole lot of learning going on. It's like, I can do this, finish that problem. I can do this one, finish that problem. Okay, I did it wrong, so do it again. Um, but not kind of understanding, and not taking the time to look at, how are these problems the same? How are they different? They might just have different numbers, but the underlying structure is the same. So having those conversations in math class, having everybody sit with a workbook and work alone, so that, sort of the idea that nobody's going to cheat or copy or something, is
Right.
really not, to me, the best way to learn math. Learning math is a social event, where you have conversations about, what does this mean, and as a result, if people learn procedures in isolation, they may know them for a week, and then they leave and they're gone. And frankly, many of our students have had those experiences. That's why they're back in adult ed. The procedures, they may have memorized them, and I've had people say, I don't care why, just tell me the steps. Well, I can tell them the steps, and that works for today, and maybe it works for tomorrow or the rest of the week, but it's not going to work for very long. So you really have to get people beyond, I just need the right answer, I don't care why. So let's look at a problem. So here, looking for the structure. So I was at a Target recently, and they were selling bananas for 24 cents each, as opposed to by the pound. So if I want to spend no more than $3 on bananas, how many can I buy? So, Eric, can you see if somebody wants to raise a hand and give me one way to come up with an answer?
Sure. People can either raise their hand and I can unmute you, or if you don't have access to a microphone, you can type it in the question area and I can be I can read your answer out loud.
Voice. Yeah.
Yep, I can be the voice for your answer. Okay. So Marvin says here, do it using units.
Explain a little more.
Yeah, Marvin, do you want me to unmute you or do you want to keep typing? Okay. Peg? Okay. Oh, no, Mike. Okay, so maybe while you're typing, I'll also call on Peg. So Peg, do you want to say?
Peg probably goes to the same Target that I do. She lives near
Yeah.
me.
Peg, do you have a microphone? No. Okay. Um, Jane says 4 quarters in each dollar and 3 times 4 is 12.
Interesting. Okay.
Chris
So
says try using real coins. Peg says I would get 10 bananas for 240.
oh, okay.
Okay, those are some variety of answers.
So those are a nice variety of answers. Um, and what's actually the important part is they all have reasoning behind them. Like Peg would say, well, I can multiply by 10 to get 240 to get 10 bananas right off the bat. I don't have to do much arithmetic. And so I know 240 will give me 10, so I can probably buy a few more than 10. And then somebody said they would use quarters.
Yeah.
I can't. Um, okay, well, why quarters?
Okay. Maybe so whoever put the quarters, maybe you can give us that. Thomas said he would divide 0.24 into 300.
Okay, and that's a good way. I probably wouldn't do that standing at the target, but
Okay.
it certainly will work.
Garcia said that she's proportions. Okay.
Ah, okay, that's an interesting way. So, and if this were in a class, I would have everybody explaining, it's kind of awkward to do it this way,
Uh,
but explaining, like how they would set that up. How would you set up the proportion? So you might say 1 over 24 is equal to X or a question mark, whatever, over 300. And um, okay, so somebody,
Jane was the quarter person, and she said that everyone knows quarters, and 24 is almost 25.
okay. Well, I'm going to take hers
Okay.
and say, okay, so what she's really saying is she knows that 25 is one more than 24. So 24 is the same as 25 minus 1. And in a class, I would have everybody describe the different ways that they would figure this out. And by having it not being a complicated problem, it's in a context that everybody understands. The numbers are nice numbers. It's not 25 cents, but it's 24 cents. So it's easy to make it 25 cents. So crafting problems is kind of part of the art of teaching, thinking what do you want to get across and what kind of numbers, what kind of situation can facilitate that. I also wanted to have a task that people could solve in multiple ways with multiple representations, multiple strategies. And so, but now I'm going to take this and build a little lesson around it. So I can say, well, 24 is the same as 25 minus 1. Nobody's going to give me an argument there. And then I can say that 12 times, so I'm going back to, was it Jane who said that 25 goes into $3? There are 4 quarters in a dollar times 3, so it's going to be 12. So I'm going to take her 12 and say, well, 12 times 24 is the same as 12 times this 25 cents minus 1 cent. And then I can say that's really equal to 12 times 25 minus 12 times 1. And those of you who remember some math might remember that this is the distributive property. You can take the 25 and multiply it times everything in the parentheses. So and if I asked Jane or somebody else exactly how much it would cost, she might say, well, there were 12 bananas at 25 cents would cost $3, but I get a penny back on each of those bananas because they were only 24 cents. So it actually will cost me $12, 12 cents less than $3. So that's the 300 cents minus the 12 cents would equal 288. Okay, so you could do that in your head, and many people probably would do that in their head at the supermarket if they needed to find out exactly how much it cost. But the idea of taking a situation that's very familiar and very accessible to most people, and then giving it an opportunity to demonstrate the distributive property or some other algebraic piece, to make it concrete. Because I remember at the beginning of every math class I took, we had to memorize the distributive property, the associative property, the commutative property, and then we never used them again. And so to actually look at the structure and, have all I did was take the 25 cents thing and say, well, how does that really work? Um, and so if you do this kind of thing in class, not every day, not all day long, but looking at structure and how the structure works, it kind of gives you a step into the algebra. Any questions, comments about this? And then we'll do something different. Hopefully I didn't lose anybody.
No? All right. So I can unmute you or you can chime in via the chat function on the question area. No? Okay.
Okay, everybody's good? Excellent. Okay, so we're going to, I hope everybody has a little piece of paper they can scribble on. And so we're going to do a little math puzzle. I'm really pretty clairvoyant. Here I sit at the other end of a computer. I can't even see you, but, I can read your brain. So what I want everybody to do on a little piece of paper is choose a number and write it down. Okay? Hopefully everybody's got their number. Okay, now add 10 to your number. Okay, write this down because it's hard to keep track in your head. All right, now take that answer and multiply it by 4. Okay, now I want you to add 60. All right, then divide that answer in half. Divide it by 2. Okay. I hope somebody didn't pick a ludicrous number like 5,280.
Or negative
Okay.
1.
Yeah, right. Somebody's going to show off. This should work with that, but that would be a good experiment.
Yeah.
Okay, now subtract 20. And then divide it in half again. Divide it by 2. Okay, almost done. Now I'd like you to subtract your original number. And now this is where my clairvoyance comes in. If you look at your number, I'm thinking that you're going to see 15.
Yes, says Garcia.
See, I'm pretty good.
Kathy says yes. Anthony says yes.
Good.
The nice thing about the webinar is when you start to do this, you know you're not going to lose money. It doesn't begin with you asking for a 20 or some other piece of currency to do it.
Okay, so hopefully you all got 15. If not, you probably made a little arithmetic mistake and you can redo it another time. But the reason we did this, other than it's cool, and other than it's an opportunity for me to show off my skills, is that I've done this many times with students, and everybody's very impressed. And I print out all the directions, and they take them home, and they show their family that they can guess the number. And you can make up any of these, and you can have students make them up. But the point is, why does this work? Why did everybody end up with 15? And I knew that they were going to end up with 15. And we can see why that works by algebra. So here's actually what's happening. So you choose a number, that was the x, and then you added 10, And so you have x plus 10. And then you multiplied by 4. So you had 4 times x plus 10, which is the same thing. Here's the distributive property again, is 4x plus 40. Okay? I wish somebody could yell if I lose somebody. So,
They can raise their hands or they can type in the
okay,
question.
type in help.
Yeah.
All right. And then you had to add 60. So you had x plus 40 from up above, and now you added 60. So you have, can you see the cursor?
Yeah.
Oh, okay. So you have 4x plus 100. Okay, you added the 40 and the 60, and you have 100. Okay, then you had to divide it in half. And this is another distributive property. You divide the 2 into 4x, and you divide the 2 into 100. And you end up with 2x plus 50. And then you had to subtract 20 from that. So you had 2x plus 50 minus 20. So then you had 2x plus 30. And you had to divide that in half again. So here's another distributive property. You divide the 2 into the 2x and the 2 into the 30. So you end up with x plus 15. And then what happened? I said subtract your original number. So you had x plus 15. We subtracted the x, and we ended up with 15. And so here you can do some of the manipulating of the algebra, but it makes sense. And you can do this as a group, and people can see how it works. And so the point of the algebra is that it didn't matter what number you chose. Like Eric may have chosen 7, and Peg may have chosen 6, and somebody else may have chosen 20, and Marvin may have chosen 33, and probably somebody chose 2,470. But each one of those can be represented by the same x. And so the idea of what a variable is, that this variable x, and of course we all know that it doesn't have to be an x, it can be an anything, and you can do this kind of stuff with things. I wouldn't use such big numbers, but you can have x just be a little box and pennies for the numbers, and you can add them and subtract them and double them and divide them in half, and the same thing works. So the idea is that the algebra is showing the generalized situation of how this works. And it's really the power of algebra, that it doesn't matter what number you chose, this is why it works, because it works for any number, and we can represent that number. Historically, we represent it with a letter. It could be a box, it could be a question mark, it could be anything. But it explains why it works.
My number was 7, so you are clairvoyant.
Wow, that's pretty
Yeah.
good. And we didn't even set that up in
No,
advance.
we did not. No.
Okay, so here's another. It's really important to have learners see that you can represent algebra or most any math in multiple ways, and it helps people get pictures, get a variety of pictures that are connected. So here we have a problem. Professor Jenkins finished the manuscript he's written by hand. He has hired, my typing isn't so good. He has hired 4 typists to type the entire manuscript. It will take the typist 9 days to complete the work. Okay, that's pretty straightforward. So how many days of typing will it take if only 2 typists are available? Anybody want to hazard a guess?
Anybody want to type in your answer real quick? 18, 18,
Okay.
18,
Okay, so I think
18. Yep.
18 is the popular answer.
Yes.
Okay, and if we're a class, I would say, how'd you know? How'd you get that? Why'd you do that way? Somebody want to explain their reasoning?
Yep. So anybody that had just typed in 18, you can type in your rationale, or I can unmute you if you want to speak. Chris says just double it. Marvin says 36 typist days.
Okay, okay, those are both really good observations, and they will um, hold us well. And if this were a class, I'd be jotting those down on a board or something so we could keep track of them. And then the next question is how many days if just one person types, which is you know, we already saw that answer was 36 days. Um, but somebody else could um, double the last answer. Two people took 18 days, so one person would take 36 days. Okay.
Mhm.
If he needs the manuscript in 3 days, how many typists are needed? And so I'm just going to move this to a table with the numbers that you were generating. So you said 4 typists would take 9 days. So 2 typists, we would put your 18 right here. 1 typist, we would put the 36 that Marvin, I think,
Yep.
said. Okay. And and then the next question is, okay, if it's got to be done in 3 days, how many typists? And I think somebody could probably come up with that.
Yep. 12 typists, Michelle says.
Okay, Michelle is absolutely right. In the class, I would see if there were any other ideas, and people would explain how they got, where their rationale came from. And you could get to that in a number of ways. You could say, well, if you divide this by 3, then you multiply this by 3, and you get the 12 here. If you have one typist for 36 days, so you divide the 36 by 3 and you get 12. There are lots of different ways to do it to get to that answer, and we could probably experiment a little bit. And so we would end up with doing this in a class, and I'm speeding up a whole class lesson, but this kind of activity. So we would have a table here. And then I would ask people to graph this data. So we have some data, and we would graph it, and people would feel a little uncomfortable because it wouldn't come out to be a line. It's a curve. And we would make some observations, like as the number of typists increases, the number of days what would happen to the number of days?
Decreases. Yes,
Okay.
says Chris.
And, I mean, and this makes sense. Obviously, if you have more people working, it doesn't take as long to do it. So the numbers have some meaning because of the context. And so to me, to help students have context around the algebra, instead of it just being naked numbers and letters, um, it it gives them an opportunity to pull in their common sense. It's common sense that if you have more typists, the number of days is going to be smaller. And if the number of days increases, like here, the number of days would increase, the number of typists would decrease. And then,
Linda, this is a point that Marvin had made in a text a few minutes ago about how, you know, paying attention and using the units is really important. You know, he said
yes,
he comes from a physics background, and he said that they use it
yes,
in physics, but he doesn't really meet math teachers who believe that they're that important, that math teachers just want the number, but that when you're talking about what the units are, that ensures that the answers are correct, right? It makes sense if you're talking about a typist day.
it helps.
You know,
Absolutely.
you could produce a number, and if you thought, well, if I know what the unit was, well, that actually doesn't make sense. I have to go back and revisit that number, you know, based upon what the unit would be.
Absolutely. And it helps um, people become intuitive about what they're doing because it makes sense to them. It has meaning. And then also sometimes, if I said, how many typists, if I needed it done in 5 days, how many typists did I need working? Well, if somebody gave me an answer that said 5 days, 7 1/5 typists,
Right. Right.
you would have to say, well, what is a fifth of a typist? It may be not a whole day, but it's
Right.
really not a fifth of a typist.
Right.
And, it's kind of like, we have people, you're setting up buses for moving a lot of people to the football game. And there's 40 people it can fit in a bus, and we've got 100 people. How many buses do we need? Well, 2.5 buses won't really get you there.
Right.
You
And
need three.
that's why when you talk about things like, using estimation, that you have to be flexible, right? Because sometimes you're rounding up and sometimes you're rounding down, depending upon the nature of the question. I mean, you can't
Right.
simply kind of use the same estimation strategy for every problem that you encounter.
That's right. If you're estimating when you're going shopping, to make sure you have enough money when you get to the cashier, you probably want to estimate up no matter what.
Right.
There are other times when it doesn't matter. You can estimate up or down, because as long as it's in the ballpark, that'll be fine.
Right.
Um, so yeah, having a context. And of course, since we're dealing with adults, people work, people want to work, people want to change jobs, all of that math is in a context. Nobody comes up to you in the supermarket and says, by the way, here's a piece of paper with 2/3 times 4/5. What's the answer? At least it
Right.
doesn't happen to me. I don't know. They don't know I'm a math teacher.
Right.
But it's, you know, almost all the time when people encounter numbers, there's a context. Even if it's figuring out taxes and it's very numerical, there's still a context. Um, and so I think it is important to make people identify the units. I think that's a real good point. Um, and yeah,
Okay.
and and then at the end, when we had to come up with an equation, I think a couple people mentioned that the number of typists times the number of days has to come out to 36. Well, once people can articulate that and make that observation, they've got the equation. So typists times days, number of typists times number of days equals 36. So if you need letters, then you have D times T equals 36 or something like that. So to help people see that a table and a graph and a equation can all represent the same thing. And the reality is most of the time to solve a situation, which one you choose may have more to do with the situation than the right way. It may be way more convenient to make a table to figure out what's going on. It may be way more convenient to have a graph to show a picture, to show somebody why this is or how this works. And often it's really convenient to have an equation or a number sentence, a number and word sentence. Um, and one isn't better than the other. They're just different. And so having people know that they can do any of those things and translate between one to the other, from one to the other, is very powerful and useful. You don't always have to do the symbolic algebra. Lots of times you get way more information from a graph or a table that really helps you make a decision or do whatever it is that you need to do. And this may be a good example coming up of exactly that. Where's my little cursor there? And this is about reasoning. And so reasoning involves drawing conclusions on the basis of evidence or assumptions, according to the National Council of Teachers of Math quote. So here we have a situation. A restaurant offers two options for salary for an 8-hour day. You can get $2.50 an hour plus tips, or you could get $8 an hour and no tips. Which option do you choose? And I think most people, if you just ask them, would say it depends. It depends on how much you can make on tips. If you can make another 550 on tips every hour or more, you're way better. And so these kinds of reasoning, and so then we could say, well, let's look at how much money the restaurant would have to pull in to assume this 20% um, tip, and you could graph that, and you could make a table with different amounts of money the restaurant would make, and you could graph both of these salaries and say, well, and use that information to make a decision. And this is really where algebra makes sense, um, and is very powerful. The tools of algebra, whether it's graphing or equations or um, uh, other representations. And so I think, um, so I thought to end with one more puzzle problem. So on your little piece of paper, I'd like you to, and I can send this to anybody, or Eric can, or we can post these. But these kind of puzzles are very easy to make, and I've had students make them. Um, but this one is a little interesting because it's different. So write your birth month. So that means January is 1, February is 2, March is 3, and multiply it by 50. Add 6, double it, add your birthday. So, the first, the second, the third of the month. Subtract 12.
That's funny.
And what do you get?
That's funny.
Okay, Eric found.
Chris says, "Wow."
But then, and I don't have it written out here, but it's very easy to then do the same thing that we did with the other puzzle to see, why does it work? What happened to make that work? Where did it come from? And that's, you can use algebra to see how it works, even though everybody has a different birth month and a different birth date.
Kathy said she wants you to pick her lottery numbers. Well, I mean, all joking aside, there was actually a guy a couple years ago who noticed a pattern on the backs of particular scratch tickets, um, and he figured out how they paid off based on this
Wow.
based on the back of the pattern. And so he went and bought a bunch of them, and so he knew, like, which ones to scratch off and things like that. And the state refused to pay out. The state said that it it was faulty, and it wasn't their fault that it was faulty, and so they didn't pay the guy the money. Um, but he didn't do it. He basically did it like as a concerned citizen. He wasn't like, I want to bankrupt the state. He was basically like, look, I can figure this pattern out. Somebody else can figure this pattern out, And so it was a real world application of, like, thinking thoughtfully about sequencing and units, and how you can notice these patterns.
Well, I think they should have paid him as a finder's fee.
Yes, yes.
Wow.
The same thing happened to the kids from MIT that went to Las Vegas. They kicked them out for
Yeah.
counting cards.
Yeah, that seems not fair.
Right.
I mean, the house has an advantage, so if somebody's good enough to count cards,
Yeah, the house always has an advantage.
well.
But I think, I mean, this also reminds me in terms of like thinking in terms of algebraic thinking as opposed to rote calculations, right? Is really the idea. And I remember being in a master when I was getting my master's. I remember being in a language and culture class, and the professor asked us one of these sample word problems where a train is leaving Chicago for LA traveling X miles an hour, and from LA to Chicago traveling X miles an hour. Um, and how long is it going to take them to meet? And whatever it was, I don't remember the exact numbers, but it was like um, one of them was traveling 60 miles an hour, one of them was traveling 40 miles an hour. And so
Whoa.
it added up to a whole unit of like it was easily 100 miles an hour combined between the two of them. And so with that 100 miles an hour, I was able to say, well, I could just divide the distance by this 100 miles an hour, and then there's your answer, right? You gave me units that added up to a really easy manipulatable
Mhm.
unit. And so she asked for the answer, and I said, okay, the answer is however many days or whatever, how many hours. And she said, now how did you do it? So I explained, okay, well, the 60 plus the 40 means it's 100 miles an hour between the two trains, and so therefore you can divide it that way. And she said, does anybody know how to do it the right way? And I was flabbergasted. I was like, all right, so this is a college professor, teaching my master's class, telling me that the way that I conceptualized the problem, recognizing what the units gave me to work with was not the correct way because I didn't plug it into the expected formulates that she wanted to see.
Yeah, that's a shame because your way probably would have made more sense to more of the people in the class
Right,
than what she was looking for.
right. And when they give you whole units, when they give you whole numbers, take advantage of them.
Yeah, absolutely. If the numbers were ugly, you would have done it a
I
different
would have
way.
done it a different way.
You would have had to.
Right,
And so, I mean, that's one of the big rules about estimating is, if you or like if you have to do a lot of computation, add up a long um, column of numbers. If you find numbers that add up to 10,
right,
you know, scattered around there, that makes sense to do that because it's easy to keep in your mind. You can scratch off a few of those numbers, and that's a really good strategy
right,
for compatible numbers.
right.
Um, and that's a horrible story.
Yeah. It also reminds me there's a classic Paddington Bear story. I don't know if people remember Paddington Bear. He's kind of a British
Uh-huh.
kid story, and Paddington finds
With
himself
food.
on a game show, and they ask Paddington the quiz question is, how long is an 8-foot board if you cut it in half? And Paddington buzzes in and says 8 feet long, and they
What?
say, no, that's incorrect. It's 4 feet long. And Paddington's like, yeah, if you cut it this way, but if you cut in half this way, it's still
You're
8 feet
breaking
long.
up
Oh,
for some reason.
so the question was, how long is an 8-foot board if you cut it in half? And Paddington says 8 feet. And they say, no, the answer is
Yeah,
4 feet. And he says, no, not if you cut it lengthwise. If you cut it lengthwise, it's still 8 feet long. And so, people in the audience were on his side, but it goes back to this kind of what's the nature of the question? Can you conceptualize what the actual problem is and what you're doing, and not simply, okay, 8 feet divide in half. Well, which half are you talking about in this case?
yeah. And this is a really serious issue when we teach adults who may have learned math in other countries
Right,
because there's this myth here that our algorithms, our routines for doing computation are correct and the best. And in other countries, they just do the arithmetic differently, and some of it makes a real lot of sense, and some of ours don't make a lot of sense. Um, and but you sometimes you have teachers who can't figure out what a foreign student is doing, or a new immigrant, and parents as immigrants have a hard time because their kids come home from school doing the math differently, and then parents struggle with, well, do I show them what I do? Are they going to be confused? They want me to check their homework. um, so the issue of different ways to do math, um, you know sometimes in class, if you have students who learn math in other countries who can show the procedures that they learned, and then you spend a little bit of time saying, why do they both work? You know, what's happening in this one, what's happening in that one, because they all have shortcuts. You don't write everything, like when you multiply two numbers by two numbers, you don't write everything down. And it's really a learning opportunity to try and figure out why do they both work, and how are they the same, how are they different, and what's the meaning of the shortcuts? What are they doing? How is it working? Um,
Hmm.
and especially this is especially true in adult ed classes, because often you do have people who have learned math someplace else.
Hmm. Well, all right, we're
Of
just
course,
about at
sometimes they don't remember very
right,
accurately the math that they learned,
right,
and so they're confused in two languages. But
right.
uh,
So we're just about at the top of the hour. So if there's
any
um,
questions?
any
Or
questions or thoughts? Yeah, Marvin points out that there's too many teachers who insist that there's only one way to solve a problem, and that he
yeah,
insists on accepting any valid method, but not all teachers can do this. The students must show or explain their method. Mm. Other thoughts that people have, or comments or suggestions to kind of keep in mind? And I will say that what we do with these NGL webinars is we're going to circulate the PowerPoint to anybody that attended, in addition to getting a certificate of attendance. And the hope is that the archived version of this will go up on the web at some point. I'm not sure when, but we'll distribute the PowerPoint certainly. And Linda, I don't know if you want to
would
say, I
any?
mean, what
Yeah, I was just going to say, does anybody have any observation from when they teach algebra? You know, what are some of the places where students struggle? I mean, one of them is integers, signed numbers, you know, and helping people. I should have done something about that, I suppose. But that's one place that many teachers struggle to help students understand and feel comfortable with signed number rules. But is there anything that from participants that they have seen or struggled with, or you know, get frustrated with in teaching algebra?
Peg says with algebra, students seem very varied in finding an answer. Jane says subtracting signed numbers is always a problem. Anthony says explaining the equal sign is always challenging. Your use of the word balance will be useful. Peg says Ajitha's experience has been the students struggle with graphing. Marvin says the common problem is recognize that letters represent numbers. Okay. I mean, one of the things I was going to say before is that at the NGL conference in the spring, I'm sure we're going to have a session on numeracy. But one of the things that we want to keep in mind is presenting multiple opportunities for professional development over the course of the year. So my hope would be, Linda, that we can have another, webinar on numeracy in the spring. And then if there's other ways for people that want to network or particularly want to keep in touch with each other around numeracy issues, that they can contact NJAL and kind of perhaps become an informal, network within the state of people that really want to keep in touch about numeracy. Because there's 23 of you on the line right now, so that's a good amount of people that are caring about this.
That's good.
Marvin says students are taught to be happy with a correct answer, even if they don't understand how they got it. Yes,
Yeah,
and they're
I agree
very
with that.
frustrated when you ask them to explain it when you've already told them that it's correct. You already told me it's correct. Why do I have to bother?
Yep.
And again, I mean, I think that goes across disciplines too, right? And thinking in terms of literacy, when you say, well, what did you think of that character? What did you think of that? Why did that character act that way? Well, I think they were jealous. Well, why do you think they were jealous? I don't know, they just were. right? And so explain to me, what in the story you're drawing on, what evidence do you see in the story that you read to come to that conclusion? Really articulate what your thinking is, and students get sometimes struggle with that too. They can kind of give you the gut response, but they can't necessarily point to textual evidence for why they're actually thinking that, which becomes
Yeah.
really important in history class. Other,
Yeah. And sometimes students will say, I don't know how I did it. I just did it in my head,
right,
which is fine, in real life. But if you want to build on the knowledge that you have and make connections,
right,
which is, part of learning math, it's really good to try and decompose that,
right.
um, and and see what you were doing. It's hard to make it evident.
Right. 'Cause you want to, it may or may not be generalizable, right? The reason that you came up with that
Right.
answer.
Yeah, I mean that's the other one is will that always work?
Right. All right. Well, it's past the hour. So I'd like to thank Linda again for having a really interesting
And
hour talking about algebra and thinking about math and ways to kind of get at the real concepts that we're talking about. So again, I'll send the information out. Please let me know if you're interested in hosting one of these, or if you have a particular idea for a webinar that you would like Angel to offer, or some other sort of professional development that we would like to offer. And I look forward to seeing you all after the new year. So have a happy and safe New Year's, and we'll see you next year.